I'll come back to this in a second. So we left off on aircraft wings. All right. I'm going to start off this time with the actual drawing because I think that's going to help understand what I'm going to write on the other side. So go ahead and draw. Get this going here. An airplane wing. Okay. So you got your airplane wing drawn in there? So again, we're going to still have the same issues with the wind. Okay.
Look at the ceiling like we're getting wet. Like it was dripping. Bad lighting.
Huh?
Bad lighting.
No, I'm cold.
Cold.
Oh, if you're cold, it's cold. Let's step my room for like 1 minute.
Oh, I know.
Oh, you'll be warm. Cut the glass. That room is warm.
All right, so there are four main forces that are acting on an airplane's wing. We've already covered this one. This is lift. The forward motion is thrust. What pulls back on it or slows it down, we can call friction or drag. Okay? And the force that pulls everything down is gravity. Hang on, gotta turn it back on. I guess I can't touch the screen with my other hand. Okay. So those are the four forces that are acting on a wing. I put a dot right here in the center, and that actually has a name. It is the center of pressure. All right. So the center of pressure is basically, think of it as the pivot point of the wing. Okay? So as the wing pivots, that's that center of pressure. Okay? Now something I want to point out, and I'm going to try a new color here. That's purple. You don't have to do the same color I'm doing. So I'm going to do a blue one now. So coming through, I'm going to try to get this as best I can. That center of pressure is another line. Now that line actually comes through the front of the wing and ends where the wing ends back here, like that teardrop shape at the tip back here. This is called the angle of attack. Angle of attack. So remember earlier on that other page, I can kind of scroll back up. I'll come back to this. Give me a sec. Oops, I took it off of there. Yeah, this one here. Remember this angle right here? Right there? That angle is the opposite side of this one. So we could do either one. But this is the angle of attack. Okay? And so that angle is important. Now I know that Well, let's put some information here first. We'll talk about angle of attack later. All right. So here are some things that I want you to have on here. So it's kept in the air by overcoming drag. So there's that one key word there. And gravity. All right, so it overcomes draggy. Wait, I just made up a new word. Gravity and drag together. Draggy. Drag and gravity. So it overcomes both of those. All right. Something important is that lift is perpendicular. There's a good word for you. Perpendicular to motion. Of the wing. Also known as the thrust. Okay, so look at this. Lift is perpendicular. Earlier, I forgot your name. Yeah, Rebecca. Earlier, Rebecca said that it was at a right angle when we were talking about this angle here, but actually it is at a right angle. So lift and thrust are at right angles to each other. Okay? Okay, I'm going to move this up. Move my picture out of the way. There we go. Back to draw. Okay. And then the last thing in this box. The magnitude of lift is related to the angle of attack. Hey guys, question. What's the big conversation? Like ever since I started, that's all you've been doing is talking. Don't ask me what words are if you're not paying attention to begin with. All right. So, that's pretty much everything for that box. Oh, I forgot one thing. This blue line has a name. It is called, oops, go back to the drawing again, hang on. It is called, I'll move it back up in a second. It's called a chord line. We'll talk about that in the next set of boxes again. So that chord line, it represents that angle of attack. That is that angle that it goes as it lifts. Okay, and that angle is what's really important. So when we're putting together our airfoil dragster cars, we're going to need to have some way to keep that angle of attack in such a way that it doesn't pivot too much. Okay. All right, so then we're going to spend a little bit more time with that angle of attack in the last set of boxes. All right, is everybody okay if I move this up? I heard a no and a yeah at the same table. Can you look at it? Okay. Somebody? That was over there. Okay, moving it up. We're now going to go to this last section, this angle of attack. Now, once we're done here, I'm going to talk a little bit more in detail about what it is you're supposed to be building. I know we started working on it last time you were in class, but I want to go a little more in depth, and then I'm going to give you some time to work on it in class. We're going to actually start building your models. Okay, angle of attack. Let's cut this again. Here we go. That is the angle between the direction of motion, or the thrust. Just kind of repeat what we did before. And the chord line. Okay, so there's that term from before, and there's another term. Okay? So that's that angle between the direction of motion and the chord line. There is a point where the air, as it flows over, will separate and cause that drag behind the airplane. Okay? This is called the separation point. Okay? And there's a sweet spot for airplane wings. Also then, there will be a sweet spot for your model airfoil dragsters. Okay? So there's a separation point, which is a place where the airflow is disturbed. Oops, I spelled disturbed. Spell that correctly here. Okay. I'm going to scoot that up just a smidge. All right, now we're going to draw 3 airplane wings. This over here. Let's see, the first one's going to be kind of flat. Whoop. Flat. Let's try it. There we go. Jabber, 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 jabber. It's like constant. And I don't know like that one either. So this one should actually have a slight angle to it, slight upward flow to it. More like that. I'm going to erase parts of it. Oh, and erase the whole thing. I just love it. And then the last one's going to be very steep angle, like that. All right, so the center on each of these is about the same spot. So I'm going to draw a line between all of them. All right, so that's going to be as close as I can get to the center of each one. Okay, so they're all pretty much on the same plane. Then you remember that it has this plane that goes this way, this plane that goes this way, this plane that goes this way. What's this angle here called? What's that angle called again? Angle of what? Angle of attack. Okay. So for each one of these, you should see a slightly different angle of attack. Now I don't know if I'm actually getting what it is I'm trying to do with my angle of attack here. Come on. But these angles here are really important. Okay. Now my last two look exactly the same, but I'm going to label them differently. Okay. So if this one here has an angle that is, I'll redraw this angle here, is 5 degrees, okay? That means we have low lift and low drag. Okay? So there's not a lot of action going on with that wing. So like I said, there's a sweet spot. So if I was an airplane trying to take off, I need that sweet spot where I'm going to get that maximum amount of lift with the minimal amount of drag so that I don't crash my airplane. All right? Mrs. Endress, you said you were taking flight lessons?
Yes.
Okay, I was too. Did you get to the point where you're flying solo?
Yep.
Okay. Did you ever have issues with landing?
When I started.
Okay. One time I was up with my pilot who came with me, and we were coming down in for landing. And as I came just about, almost hit the landing strip, a wind shear came across, and it caused the whole front end of the airplane to fly up in the air, and we almost landed on the tail. Now, thank God I had the pilot with me because he knew what to do. He jammed the airplane forward, and we landed, kind of hit hard, but we landed, didn't break anything. All right, you ever have that?
Yep.
It's a
So
little
when you're
scary.
landing, you want your plane to almost stall out. That's where it doesn't have that flow. And then at the last second, you drop it and then you land.
Yeah, except we had that wind shear come across us, and that kind of threw us out.
I learned how to do that all the time because I was in a small one strip. So I had to learn how to cross land.
Yeah, because it only had one direction. Yeah. We had two in the Freeport Airport, but we always landed on the main one. So yeah, we did learn that. So you want to make sure that you're getting the least amount of drag when you're landing and when you're taking off. Now this is kind of, you're like, well, what does it have to do with ours? We're trying to find that right angle that we can have these just kind of stay in the air without stalling. So if they take off and go like this and then land, that's a stall, okay? We want them to keep moving and get not necessarily the maximum amount of lift, but maybe around this 5-degree angle where we get low lift and low drag, okay? This one here is at about 15 degrees, and here we get maximum lift, okay, and minimal drag. Now, I said something about this separation point. There is some drag with both of these, but it's very low and very minimal. But as the airflow goes over, let me change this to a different color. That's blue. So as the airflow goes over, there's a point where it becomes separated, and you start getting these tiny little, and they call them eddies, behind the airplane wing. So these little swirls of air right behind the airplane wing. So those eddies, those create that drag that you're starting to see. And drag is basically just friction, the thing that slows things down. You've all felt friction before anytime you run or anytime you ride your bike into the wind. Maybe even when you're driving down the road in a car, a crosswind hits you and your car starts shaking like that, okay? So that is the drag or the friction, okay? Now the last one, and I know these two look very similar. This one is the one that happens when an airplane stalls. Let me go back to red. I'm going to zoom this up a little bit. I don't think it was red, it was like that color. And that is 25 degrees. Oops. 25 degrees. Okay, that's where you have high lift, high drag, and low lift. Okay, and so when the air separates, it causes these very turbulent drag eddies behind it. Okay, and that really slows it down a lot. Okay. Now, you're making an airfoil dragster. So you need to find a way to reduce the drag and give yourself a minimal amount of drift, of lift, sorry. Okay? So that's kind of your challenge, I guess, as we start this out. Okay? So I'll give you a couple seconds to finish this up. I'm going to want to collect this paper. So as you get done today, I'm going to give you credit and I'll give it back to you probably next time we're in class so that you can use this to help you if you need it. But definitely I need you to make sure that you get your name on it. This is an A day, so make sure you circle A day. And then if you could put it What happened to the basket? Well, just stick it in the basket when you're done. Stick it in the basket.
And then, could everybody have a seat real quick?
Let me turn this off so you don't have to be on camera. Unless you want to be on camera. All right. Okay, hang on a second. Oh, yeah, you can take that. There you go.
Yes.
This is available for you to look at on Empower. So I'll show you how to find it, but it is up to you to find and deal with. But for now, I'm just going to go through this very quickly. We've already covered some of this information last week, so this might look familiar. Just know that this is where you're going to find the information on how to do the next part. I read through this last week, but right here, I'm just going to go down to where it says this activity will prepare you with valuable skills of using hand tools and to further understand the design process in a fun and enjoyable way. So you're going to be creating a foam airfoil dragster. So you're going to make a dragster that doesn't have wheels, but is able to float kind of like a paper airplane, but not lift off. Okay, you just want it to kind of float along the surface of the floor. Okay, how that's going to work is you're going to be drilling a hole in the back, and it's just going to be hand drilled. I've got this big long drill. You're just going to hand drill it. I tried using the power drill, and it made the hole terribly big. It kind of moved around too much and just kind of tore the back end. So what you're going to do is you're going to put it on the launcher. This is the launcher right here. And what I will do is I'll just plug it in. Okay, so this gets plugged into an outlet. I'll have you know this was fun to make. It's a potato launcher. You know what a potato launcher is? Seen those before? Yeah. All right, so everybody listen real carefully. It's going to make a noise. Hear that? Okay, so this is just a sprinkler valve. So if anybody's done landscaping and you put underground sprinklers for people's yards, I went to Menards. It's the wrong time of year to find them, so I had to go upstairs and where they keep everything from spring and summer upstairs.
You probably need to close the Chromebook. Talon,
He probably can't hear you.
close the Chromebook, take the headphones off, please.
Thank you. So all this is a 24-volt shut-off valve is all it is. This is the doorbell. Got that from Menards also. And then you can look inside. I left the ends open so you can see where I wired everything up. The doorbell lights up, turns off when you hit the button. Just like a regular doorbell. Ding dong, ding dong. Fun, huh? And it does work on two 9-volt batteries, but I just wanted something a little more reliable, so I had this, I think it's a 12-volt charger. I just cut the end and I wired it all up. This is only 8.4 volts, so that's pretty darn good. All right, so how I get it to work is you have to charge it up. So you'll see at this back end here, I made it in a J shape so that it sits level, okay? This back end just has a pump in it. If I had a compressor, I could use that. It only takes about 15 pumps of this. Otherwise, it becomes too much pressure for this particular valve. There's better valves out there. I just didn't want to spend a ton of money on it. So let me just charge it up for you so you can see what I'm talking about. Now, the airfoil dragster that's on there is one that was made by Mr. Lascola, and there are some tools you're going to be using in my classroom. There's a scroll saw in there. This is basically looks like a giant sewing machine. It was up here on a cart last week. I think Mr. Lascola showed you. Did he cut this out while you were in the room? Okay. And I've been kind of messing with it. I've been sanding it down. I've been putting, you can see I put a little wing on it and things like that. So it's kind of ready to go, except it's missing some stuff. So I just want you to know that I lost count.
11, 12,
15-ish? Okay. All right, so if you don't like loud noises, plug your ears. It sounds kind of like a dying elephant. Okay.
You scared me again.
Already gave the warning. Get the warning.
All right, so obviously you saw how that shot off. Now I'm going to be shooting it off, thank you very much, on the ground. So we're going to have this sitting on the ground. We'll give it about 15 pumps, and then we'll launch yours. And it needs to go as far as it can down the hallway. We're going to launch him from Mrs. Enders's doorway down the hallway towards Mr. Paddock's room. Okay? So you saw very quickly. I pumped it up, we shot it off. Pumped it up, shot it off. So we're going to move pretty quickly when we get to the testing phase. And your idea is to try to see how long or how far you can get it to go, okay? Keeping in mind some of those things that we covered already. Let's see if I can do this without killing myself. No electrical charges, all right. Okay. Keeping in mind that you're trying to create some kind of an airfoil design that floats. Okay. Now notice on mine, I've added something to it that wasn't there when Mr. Lascola did it. So in the other room, everybody's been cutting pieces off, and I've just been hanging on to those pieces. So I kind of dug through it, and I found this one. I thought, hey, that's pretty cool. Maybe I can make another one on the other side and create some kind of an airfoil. Okay. And then I also found this piece in the bin. And I'm like, wow, that looks cool. Looks kind of like one of those things you see on the back of a car. What do they call that? The spoiler, yeah. But the thing with the spoiler is that it actually pushes the car down. Kind of keeps the back end tight to the ground. So I was thinking, well, what if I put the spoiler on the bottom? Would that help it lift? And would that work with this one? So I'm going to keep trying different things on this particular project that Mr. Lascola started. And I have other ones. These are what other students made last week. So this is actually one of my designs that I drew. And they're trying to work on it. And they're saying, well, like there's a couple kids who are working on it, a couple students. You can see different designs. They're not done yet. And I'm going to talk about what you're doing with your drawings in just a few minutes. I think some of you even have some drawings that are already started. So these are all the ones from last week. I'm going to say if you want to look at them, that's fine, but I don't think you need to. But if you do take one out of there, put it back. I noticed that some of them don't have names. Actually, I think they do. They should have names on them. This one doesn't have a name because it's actually my design they're kind of messing with. Okay, so how do we draw this? So how do we get this ready? So this stuff I think I talked about last week. You should already have that in there, okay? The only one is I think, Rebecca, you won't have this yet. I can help you with that, okay? If you didn't get all that stuff started last week, this would be stage one, your research. That is something you need to work on. All right, so let's talk about orthographic drawings. And I know that we started that last week, but I want to go into an actual drawing so you can see that there's kind of a little more to that. I can't get out of this. Let me out, let me out. Exit, there we go. Cool. All right, this is what you have in front of you. And I gave every one of you a new piece because I want to make sure that you set this up correctly. So as I draw this, let's say that I want to make one. This in my case, this will be my the top of my car. This will be the side of my car, but it could be the other way. This could be the top of your car. This could be the side. It's up to you. All right. But this is going to be my top. So this is my top. We'll label that top. Now I'm not going to get this paper from you. I don't want this paper because you're going to do something with this paper to create your project. Okay. So let me go with longer black. Okay, here we go. So I'm going to draw, let's say I want, I don't know, something that looks kind of like. Okay, each of these squares is 1 inch. So this is a 1 inch square. Okay? So that means that this is the same size as the block that you're going to get. This is what your block will look like. Okay? You can start that today. I've been having people drill holes in it. All right, so each one of these is 1 inch. Now, in this side, this is where the pipe goes. You're going to have to make sure you leave some space for that pipe to go in. So rule of thumb is somewhere around 2 inches should be left as part of your rocket or of your airfoil dragster. Okay, at least 2 inches so that we can put that drill in and it's going to be able to launch from the launcher. Okay. I would then have to adjust this because I think that's a little too close. So the air can maybe pop out or escape. I might want to, maybe adjust this down like that. Okay? And maybe my side view, this is the side view, so my top view, maybe I'm going to have it come up to a point like this. Now notice, I'm trying to keep it at about the same point. And actually, that's a little bit off there, so let me just erase that. So it's got to be right about there. Then I've got another set of things going on here. So I'm going to want to maybe come in like this. So these are all kind of lining up along the same planes. Okay. And then maybe this is where I'm going to have it. Maybe I'm going to have like a fin or something right here. This is going to be higher. I don't know, kind of like what I did with this one here. You'll see that this one here has a little piece that sticks up and they're trying to cut around it. They're going to sand this all down so that it's kind of rounded and then cut it out here on the sides. So again, the sky's the limit. If as you're working, you're like, oh, this totally sucks. I got like 90 of these, okay? You can work in groups of up to 2. Don't ask for 3. Don't ask for 4. And you can work by yourself, okay? So what I'm looking for you to do is start designing today. Once you have a drawing, you're going to take that drawing. Here's mine. Okay, I'm going to grab a pair of scissors. There's some in here and there's some in my classroom. And I'm going to start cutting this out. So when I get this all cut out, I'm going to cut it on the line. I'm going really fast because I gotta move on. Once you get it all cut out, I'm going to cut out the top view on this one. This one is actually done with the top view here. You're going to then take that and you're going to set it on here. In my room, there are some markers. So you're going to take that marker, you're going to trace that. That's going to help you cut it out. Take this out, get it out of the way, and then you're just going to cut where you drew your lines. Okay? Are there any questions about this? Okay. Mrs. Enders, did you want to say something before I let them work? Okay. Let me pause this.
So not all of you guys can be with Mr. Hotchkiss in that room at the same time. So while you're working on, if you're in that room doing